Okay, so we group the first two, we group the second two. We're going to figure out the GCF for each group individually. It's not for the whole thing, just for the first two terms. So when we look at the first two terms here in this example, x cubed plus x squared, what do they have in common? They have x squared in common. We're going to factor that GCF out of those two terms and only those two terms. We're going to take the x squared out of x cubed. We're left with x. We're going to take the x squared out of x squared. We have to put that plus 1 right there. Multiply back out. Check. X squared times x, x cubed. X squared times 1, x squared. Now, let's look for the GCF of the second two. If it is negative to start with, it has to be a minus. 4 and 4, they both have a factor of 4, right? If we take the negative 4 out of the first term, we're left with x. If we take negative 4 out of negative 4, we are left with positive 1. Check it. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. These, what you have in parentheses, should always, always, always be the same. It should always be the same. If it's not, you need to go back and check your GCFs and check your factoring because that should always be the exact same expression. I like to go back and underline it just to make sure that I've confirmed with myself that I have the same thing. Okay, now we put the GCFs together, and I got this from Ms. Joyner. We call this the 2-for-1 special. X plus 1 showed up 2 times, but we only write it once in the final answer. Okay, you put the GCFs together, and then it's a 2-for-1 special. They were the exact same. You only write it once. Now, you do need to check for further factoring. X squared minus 4, difference of perfect squares. X plus 2 times x minus 2. Now, will that always happen? No, but sometimes it does. We need to check for it. Okay. Any initial questions? We're going to do some more. I just want to see if there's any questions that you have at the moment. Okay, so let's do number 21. Okay, split it up however you need to, draw a line, whatever you need to do. Okay, x cubed and x squared. GCF is x squared. When we pull it out, we've got x. This time it's minus 1 because it was a minus x squared. This was a plus, so it's going to be plus 9x and 9. They have 9 in common. We pull out the 9, we're left with x minus 1. It is the exact same expression. Now, don't just write it down because you think you know it's what it's supposed to be. You got to actually factor it and make sure that you didn't make a mistake. Okay, so our GCFs go together. The x squared, the plus 9, 2-for-1 special. I know that sounds silly, but you're much more likely to remember it. Check for further factoring. X squared and 9 are perfect squares, but it's a plus. We cannot do the sum of perfect squares. It's only the difference of perfect squares. So that one is finished. Okay, let's look at 22. K cubed plus 5k squared. They have a k squared in common. When we factor that out, we've got k plus 5. If that's a minus, you've got to take the negative out. K and 5 don't have anything else in common, so we're just factoring out a negative 1. So that becomes plus k and plus 5. Check it. Multiply that out. K squared times k, k cubed. K squared times 5, 5k squared. Negative 1 times k, negative k. Negative 1 times 5, negative 5. Okay, they are the exact same expression. So we put the GCFs together. K squared minus 1, 2-for-1 special. K plus 5. Difference perfect squares. K squared minus 1 is the difference perfect squares. K plus 1, K minus 1. Yes, you have to factor the difference perfect squares or you are not fully factored. Okay, any questions with those two? Okay, let's look at 23 and 24 as well. All right, 4b cubed minus 5b squared. 4 and 5 don't have anything in common, but both of those do have b squared. So we've got 4b minus 5. That 16 is negative, so we got to take out a negative. 16 and 20 have a factor of 4. Negative 16 divided by negative 4 is positive 4. Still has the v. 20 divided by negative 4 is negative 5. You have the exact same expression, so we're good. GCFs go together. 2 for 1 special. B squared minus 4, difference of perfect squares. B plus 2, B minus 2. Now, here's another way that you can check this. When you get to, in this case, we've factored the difference of perfect squares. If you go to the step above that, if you multiply that out, b squared times 4b, 4b cubed. B squared times negative 5, negative 5b squared. Negative 4 times 4b, negative 16b. Negative 4 times negative 5, positive 20. You can at any step in this problem, you can multiply things back out to check to see if you have the original expression. All right, one more. 2x to the 5th minus 18x to the 4th. We need to pull out a 2x to the 4th there. When we do, we've got x minus 9. We need to pull out a positive 7 out of the second 2, and we're left with x minus 9. The exact same expression, which is what's supposed to happen. Put those GCFs together. 2 for 1 special. Check for the difference of perfect squares. We don't have the difference of perfect squares, so we're finished.